Hello, everyone. Welcome to this bridge course of Business Mathematics, Part 6. Today, we will talk about production function. In the last part, we talk about partial differentiation, the basic of partial differentiation, how to differentiate with respect to x, taking y as a constant, and how to differentiate with respect to y, taking x as a constant. We also talk about Euler's theorem. We talk about the degree of homogeneous equation, and we discuss some question on Euler's theorem. Then we talk about how to find out second order partial derivative. Today, we are talking about production function. So whenever we have any production function is a function of labor and capital. For example, we have a production function twice of labor to the power zero point 0.4 and capital to the power zero point 0.6. Find average productivity of labor, average productivity of capital, marginal productivity of labor, and marginal productivity of capital. What do you mean by that? We say APL, इसे हम एवरेज प्रोडक्ट ऑफ लेबर भी बोलते हैं। यानी कि अगर हम कहते हैं कि एवरेज प्रोडक्ट ऑफ लेबर, तो यहाँ पे आएगा प्रोडक्शन डिवाइड बाय लेबर। अगर हम पूरे प्रोडक्शन को लेबर से डिवाइड करें तो हमारा आंसर क्या आ रहा है? ट्वाइस ऑफ लेबर टू द पावर 0.4 के टू द पावर 0.6 डिवाइड बाय लेबर। अगर यहाँ पावर्स को सॉल्व करें तो ये होगा 2 के टू द पावर 0.6 डिवाइड बाय लेबर टू द पावर 1 माइनस 0.4 इज 0.6। आंसर इज ट्वाइस k upon L to the power 0.6. Next, average product of capital, the whole production divided by capital. This is twice of labor to the power 0.4 k to the power 0.6, the whole divided by capital, that equals to twice of labor to the power 0.4 k to the power 1 minus 0.6 is k to the power 0.4. Again, we have answer in the ratio of labor and capital 0.4. Now, marginal product of labor. This implies partial derivative of production respect to labor taking k as a constant. So now this is 2 k to the power 0.6 is constant. Now what's the derivative of labor to the power 0.4? It is 0.4. Labor to the power 0.4 minus 1 is minus 0.6. So the answer is 0.8 k to the power 0.6 divided by labor to the power 0.6, and this is 0.8 k upon L to the power 0.6. Now marginal productivity of capital. In this case, we calculate partial derivative of production with respect to capital, that equals to twice of labor to the power 0.4 is a constant. Now the derivative of k to the power 0.6, it is 0.6 k to the power 0.6 minus 1 is minus 0.4 equals to 1.2 L to the power 0.4 divided by k to the power 0.4. This is 1.2 labor upon capital to the power 0.4. Please note here, whenever we calculate APL, APK, MPL and MPK are always in ratio of labor and capital. So remember this, whenever we calculate APL, APK, MPL, MPK, they are always in the ratio of labor and capital. Now we talk about homogeneous production function and return to scale. अगर आपके पास कोई भी प्रोडक्शन फंक्शन गिवन है, विच इज अ फंक्शन ऑफ लेबर एंड कैपिटल, just replace labor by lambda L, k by lambda k. And if this equals to lambda to the power n, function of labor and capital, it is called to be homogeneous production function of degree n. अब यहां पर डिग्री n का लॉजिक क्या है? अगर आपके पास n इक्वल टू 1 है, कांस्टेंट रिटर्न्स टू स्केल। इसका मीनिंग ये हुआ कि अगर आपने प्रोडक्शन डबल करना है तो आपको लेबर और कैपिटल का इनपुट भी डबल करना पड़ेगा, और अगर आप लेबर और कैपिटल का इनपुट ट्रिपल करते हैं तो प्रोडक्शन ट्रिपल हो जाएगा। और अगर आपके पास n इज मोर देन वन, दिस इज कॉल्ड इंक्रीजिंग रिटर्न टू स्केल। इसका मीनिंग क्या हुआ कि अगर आपने लेबर एंड प्रोडक्शन को डबल किया तो आउटपुट जो होगा वो डबल से ज्यादा होगा, और अगर ट्रिपल किया तो आउटपुट ट्रिपल से भी ज्यादा होगा। और अगर आपका n लेस देन वन है तो इसे बोलेंगे हम डिक्रीजिंग रिटर्न टू स्केल। इसका मीनिंग ये है कि अगर आपने लेबर और कैपिटल को डबल किया तो जो प्रोडक्शन का इंपैक्ट आएगा वो डबल से कम आएगा, यानी कि इसमें डिक्रीजिंग रिटर्न टू स्केल होगा। तो यहाँ पे हम दोनों इनपुट्स की बात कर रहे हैं, हम दोनों इनपुट्स को सेम रेशियो में इंक्रीज कर रहे हैं, तो उसका इंपैक्ट देख रहे हैं हम प्रोडक्शन के ऊपर। We'll explain with the help of an example. For example, we have a production function, is a function of labor and capital, which is given to us 1.2 labor to the power 1 by 3 capital to the power 2 by 3. Check return to scale using this production function. So what we'll do that, पहले हम L को रिप्लेस करेंगे lambda L से और K को lambda K से। ये आ रहा है 1.2 lambda L to the power 1 by 3 lambda K to the power 2 by 3. If we simplify this, it is 1.2 lambda to the power 1 by 3 labor to the power 1 by 3 lambda to the power 2 by 3 and K to the power 2 by 3. So this is lambda to the power 1 by 3 plus 2 by 3 is 1 into 1.2 L to the power 1 by 3 K to the power 2 by 3 equals to lambda to the power 1 into production function, or we can say the function of labor and capital. Here power is 1, so it is homogeneous production function of degree 1. So constant returns to scale. We can verify this also. हमने यहाँ लेबर को भी डबल कर दिया और कैपिटल को भी डबल कर दिया। नाउ लेट्स सी द इम्पैक्ट ऑन होल प्रोडक्शन। 2 L to the power 1 by 3 into 2 K to the power 2 by 3. When we simplify this, 1.2 to the power 1 by 3 L to the power 1 by 3 to the power 2 by 3 K to the power 2 by 3. So 2 to the power 1 by 3 into 2 to the power 2 by 3 is 2 into 1.2 into labor to the power 1 by 3 K to the power 2 by 3. तो देखिए आपका जो प्रोडक्शन है वो पहले से आपका कितना हो गया, डबल हो गया। दैट्स व्हाई इट्स कॉल्ड टू बी कांस्टेंट रिटर्न टू स्केल। Check one more example. If production function is given to us, which is a function of labor and capital, 1.3 into labor to the power 2 by 3, capital to the power 2 by 3. Check return to scale. Then find return to scale. Now, in this question, we replace L by lambda L and K by lambda K. It is 1.3 lambda L to the power 2 by 3, lambda K to the power 2 by 3. This is 1.3 lambda to the power 2 by 3, L to the power 2 by 3, lambda to the power 2 by 3 into K to the power 2 by 3. अगर हम देखिए लैम्डा की पावर्स को ऐड करें तो ये आ रहा है लैम्डा की पावर 4 by 3 इंटू 1.3 labor to the power 2 by 3 capital to the power 2 by 3 equals to lambda to the power 4 by 3 into production function of labor and capital. Because यहाँ पे power 4 by 3 है तो we call, so it is homogeneous production function of degree 4 by 3, which is greater than 1. So we can say that here return to scale is increasing, or you can say that increasing return to scales. Now the next point. Suppose we have homogeneous production function of degree n. So we can say that we have this production function, which is a function of labor and capital, is a production function of degree n. Then total amount paid to labor. What do you mean by this total amount paid to labor? If each labor is paid equivalent to the marginal product of labor and total amount paid to capital, where each capital is paid equivalent to the marginal product of capital, always be equals to n times of p. एंड नाउ अगर n का वैल्यू मोर देन वन है, लेस देन वन है और इक्वल टू वन है, तो जो अमाउंट पे किया हमने लेबर और कैपिटल को, क्या वो प्रोडक्शन से लेस होगा, ग्रेटर होगा, इक्वल होगा? तो इससे हम डिसाइड करेंगे कि प्रोडक्शन ओवर एग्जॉस्टेड है, अंडर एग्जॉस्टेड है या फिर फुली एग्जॉस्टेड है. नाउ जस्ट सी हियर, इफ n equal to 1, n equal to 1, then we can say that total amount paid to labor and capital equal to 1 times of p. Or we can say that total product is exhausted. और if n is less than 1, तो जो आपने अमाउंट पे किया लेबर को और कैपिटल को, वो क्या है? वो आपका लेस देन पी है. सो टोटल प्रोडक्ट इज नॉट एग्जॉस्टेड, क्योंकि जो आप पे कर रहे हैं वो लेस देन पी है. और इफ n इज मोर देन 1, the total amount paid to labor and capital is more than production. So we can say that total product is over exhausted, क्योंकि आपने जो पेमेंट किया है वो मोर देन प्रोडक्शन हो गया. We will explain with the help of an example. Just see here, suppose we have a production function of labor and capital which equals to 0.6 labor to the power 1 by 4, capital to the power 3 by 4. Find out total reward paid to labor plus total reward paid to capital, where each labor and capital paid equivalent to their marginal product equal to production. And we can say that production is exhausted. To solve this is very simple. Check that. First we check, find out the degree of homogeneity. तो हम क्या करेंगे, लेबर को लैम्डा एल से और के को लैम्डा के से रिप्लेस करेंगे. तो यहाँ पे आ गया लैम्डा एल टू द पावर 1 बाय 4 लैम्डा के टू द पावर 3 बाय 4, दैट इक्वल्स टू 0.6 लैम्डा की पावर 1 बाय 4 एल की पावर 1 बाय 4 लैम्डा टू द पावर 3 बाय 4 के टू द पावर 3 बाय 4. तो अगर हम लैम्डा की पावर्स को ऐड करें, इट बिकम 1. 0.6 lambda to the power 1 by 4 k to the power 3 by 4. So this is lambda to the power 1 and your production function of labor and capital. So it is homogeneous production function of degree 1. So according to Euler's theorem, अगर आपको याद हो, हमने यूलर्स थ्योरम में बताया था कि L टाइम्स ऑफ डेल पी बाई डेल एल plus k times of del p by del k always be equals to n into p, and here n is 1, so this is equal to 1 times of production. So we can say that when the total amount paid to labor and total reward paid to capital equal to product or production, so total product is exhausted. Now we talk about diminishing return to factors. To prove diminishing return to factors, first we find partial derivative of marginal productivity of labor respect to labor and the partial derivative of marginal productivity of capital respect to capital. If the both are negative, then we say we have diminishing return to factors. इसका मीनिंग क्या है? अगर मैं कहता हूं कि मुझे कैपिटल को कांस्टेंट रखना है, आई एम चेंजिंग लेबर, तो जो प्रोडक्शन में जो चेंज है वो सेम रेशियो में नहीं होगा जिस रेशियो में लेबर चेंज हो रही है. सिमिलरली इफ यू आर टेकिंग लेबर एज ए कांस्टेंट चेंजिंग द कैपिटल, तो जो चेंज इन प्रोडक्शन है वो उस रेशियो में नहीं होगा जिस रेशियो में चेंज इन कैपिटल है, और वो हमेशा उससे लेस होगा. दिस इज व्हाई इज कॉल्ड डिमिनिशिंग रिटर्न्स टू फैक्टर्स. We will explain with the help of an example. Suppose a production function is given, which is a function of labor and capital, is given 20 multiplied by labor to the power 1 by 3 and capital to the power 2 by 3. Find the behavior of factors. So first of all, we find out marginal productivity of labor. तो मार्जिनल प्रोडक्टिव लेबर के लिए करेंगे 20 इंटू के टू द पावर 2 बाई 3 तो कांस्टेंट है, एंड द पार्शियल डेरिवेटिव ऑफ लेबर दिस इज 1 बाई 3 लेबर टू द पावर माइनस 2 बाई 3 एंड दस इक्वल्स टू 20 बाई 3 labor to the power minus 2 by 3 into capital to the power 2 by 3. Now, partial derivative of marginal productivity of labor with respect to labor, that is 20 by 3 multiplied by minus 2 by 3, labor to the power minus 2 by 3 minus 1 is minus 5 by 3 into capital to the power 2 by 3. So your answer is minus 40 by 9, labor to the power minus 5 by 3 and capital to the power 2 by 3. This is negative. And now marginal productivity of capital, the partial derivative of production respect to capital taking labor as a constant. तो उसका जो पार्शियल डेरिवेटिव वो क्या होगा 2 by 3 k to the power 2 by 3 minus 1 is minus 1 by 3. So answer is 40 by 3 L to the power 1 by 3 and k to the power minus 1 by 3. Now the partial derivative of marginal productivity of capital with respect to capital, 40 by 3 into L to the power 1 by 3 is constant, and the derivative of this is minus 1 by 3 k to the power minus 4 by 3. When we simplify this, we will get minus 40 upon 9, labor to the power 1 by 3 and capital to the power minus 4 by 3. Both are less than 0. The partial derivative of marginal productivity with respect to labor and the partial derivative of marginal productivity of capital with respect to capital, the both are negative. So we can say that here we have diminishing returns to factors. Hope it is helpful. Thank you.